Hello students, today we are going to start our next topic number 1.4, fundamental forces in nature. Fundamental means basic. In our day-to-day life, we observe and we apply many types of forces. To move a object from one place to other, we apply the force, and that force is due to muscle power, because if I want to move an object from one place to other, then I need to apply the force, and that force is due to the food I eat, or in other words, it is the muscle power used by me. Vehicles moving on a road, they are also due to some kind of forces. Planets, they revolve around the sun. So in this case also the force exists. If an object is moving on a surface, then after covering some distance, it slows down and then finally it stops. It stops because of the frictional force. There is a friction between the two surfaces. So frictional force is also a type of force. Then to pull a spring, a force is required. So if I want to stretch this spring, then I need to apply an external force. And also, when this external force is applied within a spring, inside it, a restoring force is also produced in a spring due to change in its length. So this is also a type of force. So there are many kinds of force we come across in our day-to-day life. Now here it is given that Newton has given a clear-cut concept of force. In earlier times also, before Newton also, many scientists, they have given the concepts or the theories related to forces. But some of those theories gone wrong, and finally Newton had given the clear laws related to force. And we know that Newton had given three laws of motion as well as the universal law of gravitation. Among all the forces, few forces, they are fundamental, means basic forces. All other forces are derived from this basic or the fundamental forces. Now, first among the four fundamental force is a gravitational force. Now, this gravitational force acts between any two particles having mass. So here in figure, let this m1 and m2 be the two masses. If these two masses, they are separated by a distance r, then the force will act between these two particles, and this force is given by the formula F is equal to G m1 into m2 upon r square. Means this force is directly proportional to the product of the masses, and it is inversely proportional to the square of the distance between the two particles. And here this G, capital G, is nothing but it is a universal constant of gravitation. So the basic thing required for this force is mass. If the particles they have mass, then definitely force will act. This force is always attractive in nature. Means if there are two particles having masses, then one particle will attract the other particle. That means if this is the first particle, then it will attract the second particle, as well as this second particle will attract the first particle. So this force is always attractive. Next thing is, it is a long range force. Means if these two particles are close to each other, then also the force will act. And if these two particles they are very far away from each other, then also the force will act. The only difference is that when the particles they are close to each other, the force will be strong, and if these particles are very far away, then the force will be weak. Because here we can say that this force is inversely proportional to the distance between the particles. So as the distance increases, force goes on decreasing. Next is no medium required. Means for the action of this force between the two particles, if there is a medium between it, then also force will act. And if there is no medium between these two particles, then also force will act. Means medium is not necessary. Next point is, it is weakest among all the four fundamental forces. Means here we are studying the first fundamental force, and rest of the three are remaining. But among this all the four fundamental forces, this force is weaker compared to that other three. Students, here given that this force is quite weakest, but still the planets they are revolving around the sun, that is due to this force only. Even the satellites revolving around the planets, that is also due to this force only. Students, you will study about this gravitational force in standard 11. There is one separate chapter related to this gravitation, chapter number 8. Now next is electromagnetic force. Now, as the gravitational force depends on mass, similarly the electromagnetic force depends on the charge of a particle. We know that there are two types of charges, positive charge and a negative charge. So if the two charged particles they are separated by a distance r, then the force will act between the charges q1 and q2, and the formula is similar to that of the gravitational force. This force arises due to the product of the two charges, and it is inversely proportional to the square of the distance between them. Here also there is a constant k. As in gravitational force the constant was capital G, here this constant is k. Next point says that this force can be attractive or repulsive. They are attractive if the charges are unlike, means if one is positive and the other is negative, then these two charged particles will attract each other. But if the two charged particles are like charges, means if both are positive or both are negative, then there will be a repulsion between these two particles, means there exists a repulsive force. Again, like gravitational force, this force is also a long range, means if the two charged particles they are very far away from each other, then also this force exists, but that force will be quite weak. Next point says that again no medium required, as in the gravitational force. If there is a medium between the two charged particle, then also force will act. If there is no medium, then also force will act. Next point is it is weaker than the strong nuclear force. You will study this strong nuclear force in next part. So this force, electromagnetic force, is weak compared to this strong nuclear force, but it is stronger than the other two fundamental forces. Next is about strong nuclear force. Now, strong nuclear force exists within the nucleus. We know that in an atom there is a nucleus and electron they revolve around this nucleus. So this strong nuclear force exists within the nucleus only. Within the nucleus means inside the nucleus there are several particles. There are protons, there are neutrons, and also many other 100 types of particles. So this strong nuclear force exists between these particles. Next point says that even these forces are also attractive in nature and they are independent of charge. Means if we consider protons, we know that proton has a positive charge. So between these two protons, this force will act. But this force is not due to their positive charge. There is some other reason behind it. So this force is independent of the charges. Even the force will act between the two neutron also, between two proton as well as between proton and a neutron. Next thing about this force is it is a very short range. See, the earlier two forces, gravitational force and the electromagnetic force, they were long range force, but this force is having a short range of the order of 10 raised to minus 15 meter. That means this is within the size of a nucleus. The size of nucleus is also of the order of 10 raised to minus 15 meter. Means if these particles have this much small distance, then only this force exists. Otherwise, if the distance increases beyond this range, then this force will disappear. Last point in this is given that it is the strongest among all the fundamental forces. That out of these four forces, the strong nuclear force is the strongest compared to other forces. Now next and the last among these four is weak nuclear force. See here, the word nuclear is there. So here also this force exists between the particles of a nucleus among the interaction of these nuclear particles. This force appears between the process like beta decay. Now this beta decay is a process in which the nucleus emits the beta particles. So in the process of beta decay, nucleus emits electrons and a chargeless particle called a neutrino, and these particles they interact, and their interaction is nothing but the weak nuclear force. Again, this type of force is also a short range force, means of the order of 10 raised to minus 15 meter. Students, here one thing we need to remember, that the strong nuclear force exists within the nucleus, inside the nucleus, but this weak nuclear force exists when the particles they are coming out of the nucleus during this beta decay, and when they come out they interact among each other having this much short distance. In that case, this weak nuclear force arise. Finally, the next point says that it is the stronger than the gravitational force, but it is weaker than the other two forces. Even a strong nuclear force is believed to be the quark force. Now, what are these quarks? So, it is believed that these protons and the neutrons which are inside the nucleus, even they are made up of these quarks. So actually this strong nuclear force is a quark force. Now here in this table 1.3, the comparison between these fundamental forces is given. You can see the relative strength between this force is given, their range is given, and where they operate or among which they operate, that is also given. From the table it is clear that if we consider the strongest force, that is strong nuclear force, as having strength 1, then compared to this strong nuclear force, what is the strength of this electromagnetic force, what is the strength of this weak nuclear force, and what is the strength of this gravitational force can be easily understood. So here, starting from the topmost force, this is the weakest, then next will be weak nuclear force, then next will be electromagnetic force, and finally the strongest is strong nuclear force is given. Students, have a habit of reading each and every line of the textbook, because in this video lecture we cannot include each and every line of the textbook. So I hope you all are doing your work regularly and also have developed the habit of reading textbook.